Okay, so we're going to make use of lots of this to write a program that certainly I would have found useful when I first moved here and was not tipping and offending everyone. Is a tip calculator. So as I said before, when it comes to writing a problem, first think about the pseudocode, think about how you might code it if you could talk to your computer and give it individual commands in plain English, and figure out the algorithm that you're going to take to solve the problem first, line by line, and then convert that plain English code into Python code. And so here's how I might figure out how to do a tip calculator. So I'm going to first need to set how much the meal cost, maybe set the tax rate and what tip percentage I want to tip. And then I'm going to calculate how much the meal is with the tax, and then I'm going to calculate how much the meal with the tax is if I add on the tip percentage, and then I'm going to return that. So that's my algorithm for calculating this tip. I then convert that into Python code on the right-hand side. So everyone can open a text editor, use the same text editor you were using yesterday. Make sure that any of the settings that you changed yesterday have still, it's remembered them, because text edit has a habit of turning smart quotes back on. So make sure your smart quotes are off by going to Edit, Substitutions, and unticking smart quotes. And make sure that you have rich text formatting off. So if you see a bunch of fonts and bolds and underlines at the top of your screen, you can go to Format, Make Plain Text, and it will turn that off. So in a new text document, you can copy what I have on the right, and I'll tell you what this code does right now. So the first thing I start with is a code comment. Remember that a code comment is any line that starts with this pound sign. That's going to be ignored by Python. It's a note to myself so that when I look back at my code in a month or a year's time, that I know what the code does. Then I define 3 variables, one of which is my meal cost, one of which is the tax rate, and one of which is how much I want to tip. In this example, 15% and 7.5% tip. So we've seen lots of variable definitions before. We're defining 3 floats here. And then the next task is to calculate how much the meal would be if I add on the tax amount. So meal equals its current value plus the meal multiplied by the tax rate. So that will add on whatever the tax should be to the meal cost. And then this final total variable should be whatever that meal cost was plus the meal multiplied by the tip, so plus the tip percentage. So then we finally have this total value, which should be everything, meal and tax and tip. I just need to return it, and I'm going to use a print statement to return it. Now this print statement looks similar, but slightly different to some of the ones we've used before. We've done print, and we've had a %s, and we've substituted in some string. So we did, my name is Simon, and I am learning Python, and we had those %s signs in there. This is very similar, except rather than a %s, we have a %f, and that means I'm going to put a number in here, I'm going to put a float in here, and I want to substitute in some number with decimal information. So you could just put %f and not have the 0.2 in there, but the 0.2 is a way of saying that I want this to 2 decimal places. So because we're dealing with currency and any more information is unnecessary, we can do %.2f, and that will tell Python that we want to substitute in a float, a number, to 2 decimal places into our print statement. So you can add other words into this. If you want, within the quotes, you could write the total value is colon space %.2f, and then what it will substitute in at the %.2f is this variable here, total. So remember, we had %f, and then previously we had %s, and then we had a percentage sign, and then we had name or lang, and it's substituted in those variables. This is just the same, except we're substituting in a float to 2 decimal places. So this total variable gets substituted in, and hopefully when we run this script, it will be printed to 2 decimal places. So when you've copied all that, make sure to save it in whatever location worked for you yesterday, so probably your home directory, and call it something like tipcalculator.py. And then I'll show you how to run this. So previously we've been working with modules. We've been writing functions and importing them into Python. You'll see there's no function definition in here. This is just a script. Remember I talked about the interactive environment as one way of running Python, scripts as another way, and modules as another way. Yesterday we wrote a module that imported the starts with ATC function we wrote. So here we're going to write a script that doesn't define any functions, and so we don't need to, this is not a module, it's a script. We're not going to import it into Python, we're just going to run it as it is, and it will give us some defined output. So once more, the difference between a script and a module is that a script will be a bunch of code that we just run a single time and gives us an output. A module defines some functions that we import into Python and then can use. So this doesn't define any useful functions for us. All it does is lets us calculate this meal value. So go back to your command line and then exit out of Python. So you don't want these arrows at the start of the line. So we're going to type exit. I typed ls to check that my script is in this folder that I'm currently in. You may need dir if you're on Windows, but have a look to see whether tipcalculator.py is present in your current directory. If it is, you should be able to run python space tipcalculator.py, and it will run the script you just wrote and hopefully print the output back to the screen, and you should see a number. And let me know if you get the same number or a different number. Let me know if it works. And if you have errors you need me to debug, let me know and I'll come around. But to run any Python script, you can just type python space the name of the script, including the .py. When we were doing the modules, we didn't necessarily need to type the .py, but here we do. And it will run all the Python commands in the script and hopefully show all the output to the screen. Okay, so that was great. However, if we want to change the value of our meal, if we have a different meal that costs a different value, or we want to tip a different amount, we don't want to have to open our text document, change our code, save it, rerun it. What we want to have is a tip calculator method that takes some number from the command line and uses it in the code. So what we would ideally like is to be able to run tipcalculator.py and after the name of the function type something like 55 for a $55 meal and maybe a tip amount. So rather than having to change our code every time, we would like to be able to take the arguments from outside of Python and pass them in. So we're going to figure out how to do that, and the key to that is a module called sys. So we're going to need to import this sys module, and specifically we're going to need a list called sys.argv. So sys.argv is a list of strings, and that list contains all the parameters that are passed to Python. So for example, this 55 will be in sys.argv. But let's figure out what's in that list. Okay, so we're going to leave the code as it is, and I'm going to briefly show you how to go through sys.argv and figure out what's in there. So we're going to leave most of the code the same, just put some enters before your code, and then we're going to just add this little bit at the top, which will first import sys, and then we're going to use this for loop, which I'll introduce in more detail in a minute, but just for now, we're going to, for every argument in sys.argv, print that argument. And what that will do is it will go through this sys.argv list and print all the elements in that list for us. So the reason I'm doing this is just so we can explore what is in sys.argv and figure out which elements we need to make use of to do our tip calculator. So once you add that little loop at the top of your code, you can then be aware, by the way, of the colon, new line, and indentation for your for loop. Make sure you get the same. You can then run your code again, save that, and then you can run it again with Python tipcalculator.py. But then after the py, I want you to put a space, and then some words, a space, and then another word, a space, and then another word, just so you can figure out what's in this sys.argv list. And when you run this code, what you should see is the last thing printed is still the same result, because we didn't change our code at all, so you should still see this 55.01 printed on the screen. But before that, you should see a bunch of other strings. You should see whatever you typed after the word Python printed on the screen. So we should see tipcalculator.py, then arg1, then arg2, then arg3. So what this is telling us is that the first element in sys.argv is the word tipcalculator.py. The second element in sys.argv is this arg1, which is the first thing we typed after our program name. The next thing in sys.argv is arg2, which is the next thing we typed after our program name. So what this is telling us is that sys.argv0 isn't going to be much use to us. That's always going to be the words tipCalculator.py. So we can't make use of that for our meal value or our tip value. But what we can do is use sys.argv1 and sys.argv2 to contain useful values. So we can imagine that if we run python tipCalculator.py, rather than the word arg1 here, we could put some meal value, and rather than arg2, we could put some tip value, and then when we run our code, we can make use of sys.argv1 and sys.argv2 to use those values. So now that we know which elements of this list are useful, and that we know that sys.argv0 is not useful because it contains just the words tipCalculator.py, we're going to change our code a little bit to make use of this. Okay, so the code on the left is what we had, the code on the right is what we're going to change it to. We still need to import sys. We're going to get rid of the for loop because we don't need to loop through this anymore. This was just testing to figure out what's in our sys.argv. I still have my code comment, and most of my code looks the same. The only difference is rather than a hard-coded 44.5 and 0.15 for my meal value and my tip value, I'm using sys.argv1 and sys.argv2, which we know are the first two things after the words tipCalculator.py. Let me just check my next slide a second, sorry for jumping. Okay, so the eagle-eyed among you will notice a problem with this. So I told you that sys.argv contains a list of strings. It contains all of the words written after the word Python. And our code tries to do maths on these strings, right? It tries to do meal plus meal multiplied by tax. And it tries to do meal plus meal multiplied by tip. So what do we need to do to tweak this code to make it work, rather than knowing that sys.argv is strings? Can anyone think of a way of changing this to make sure it would work? Yeah, perfect. Okay, so we have sys.argv1 is a string, but what we want is to store it as a number that we can do something with. So rather than just writing meal equals sys.argv1, what we're going to write is meal equals the float of sys.argv1. And that will convert sys.argv1 into a float and store it in meal. We need to do the same for tip. Tip is equal to float of sys.argv2. So if you make those changes to this code, it should work fine. And when you run it, we can run it with the line Python tipCalculator.py, and then you can put some meal value, for example 55.01, and then some tip value, for example 0.18. And if you run your code using this, and you've got your float casting in there, you should see that you can see the result printed to the screen, and you can give different meal values and different tip values without changing your code every time, and see the different results back. Mm-hmm.
Is the sys.argv, so that's like, that is this on, that's the way that you're supposed to write it if you're going to do this, or is like sys something that we're putting in right now, and argv is so I thought like Python, like the function was the second thing after that.
So some modules define, modules define both functions and variables. With the math module, we saw math.square root, but also math.pi. And this is similar. sys.argv is a variable defined by the sys module, but there are also sys.other functions and variables and stuff. So because this is a variable, not a function, we don't have those curly braces afterwards. We're not running a function. We're just getting elements from a list. So it's a bit like math.pi.